Okay, this is a cyclic process. Okay, no, let's go for indicating all the things. So I agree this. So let this be the pressure graph. Let this be volume V naught, or select a V1, V2. The gas will undergo a process, cyclic process. I'm calling it as so. There should be A, B, C, D. All of you cyclic clockwise. So let's see that in cyclic process, this is a clockwise cyclic process. So the gas will start at A. Again, it will return back to A only, no? So what is the change in int ng? Will be 0 for all cyclic process. So what is change in int ng? Will be 0. Will I agree? Let it be circle or any other thing. Means the reason for that, what is the change in int ng? nr gamma minus 1 delta T. If the initial and final state of the gas are same, then what does it mean? It is undergoing cyclic process. What actually we are doing? We are first increasing the pressure volume. Next, what we do, I'll increase volume, pressure decreases. Then what I do, I'll decrease pressure and volume both. Then I'll increase pressure, I'll decrease volume. So how it is possible? The same piston and that particular vertical tube, or so like a cylinder. I can move the piston in such a way that I can bring the such variations. Let me have water. You take water. Okay, no. What is our basic imagination? Again, the cylinder. Say that never deviate from things. So you should have this imagination. There's a piston. So I am going to move so there's a pressure, volume, temperature. The piston is moved in such a way that first here for path AB, pressure, volume increases. Here, volume increases, pressure decreases. Then volume, pressure both will decrease. Volume decrease, pressure increase. I can move piston. Then again, what when I'm going to bring it back again to original value. What is the original value? The pressure is PA and volume is V1. So I'll move it in such a way that again the gas will come back to its original state. So what is the change in intensity? Will be 0. So for all cyclic process, what is the conclusion? For all cyclic process, delta U will be 0. Change in intensity will be 0. There's a very important thing. Okay, let's calculate the work done. Area under the curve. What is the area? Area of circle. That's all. So work done by the gas should be equal to area in PV diagram. So what is this area? Pi r square. So pi into r into r. What is 1 r? What is one radius? V2 minus V1 by 2. What is the other radius? P2 minus P1 by 2. So therefore this will be pi Now you can ask question. Why you are? Why don't you write V2 minus V1 whole square? I think dimensionally it will not be correct. No? So therefore, one R should be done for volume, other R should be taken for pressure. So here, what is the diameter? P2 minus P1 by 2 will become radius. What is the diameter? Horizontal diameter, this one. V2 minus V1. So therefore, V2 minus V1 by 2 will become radius. I'll get the pressure. How to say it is a work done positive or negative? I think that's cross check should be done. No? Okay, let's do one thing. So there's the first time, no? So we'll try to have a firm conclusion so that will be easy for us. So this is the look at the area, no? There's a volume V1, V2. So this is A, B, C. This is C, D, and A. Which W, A, B, C, and this is W, C, D, A. Which will have more magnitude?
ABC.
ABC is having more magnitude. You can see now. WABC. I'm talking about magnitude first. CDA, which will be positive, which will be negative. WABC is positive. WCDA is negative. Any reason for that? Volume decreases. You can ask question. As it moves from A to C, volume increases. No, as it moves from C to A, the volume decreases. CDA along the path. So therefore, work the negative. So definitely the positive, higher positive value minus lower negative value. The resultant will be positive. So therefore, clockwise cyclic process, work done will be positive. Agreed? Counterclockwise, work done will be negative. So for clockwise cyclic process, what are the conclusions? Delta U for clockwise. For clockwise cyclic process, first one, delta U 0. Work done, net work done by the gas. Net, we are talking about net, will be positive. So then what will happen to heat exchange will be negative, positive. You should not think, sir, here it is doing negative work. Okay, I'm not saying it will not do any work, negative work. It does negative work. Net positive work is greater than net negative work. The resultant will be positive only. So therefore, for clockwise cyclic process, change in intensity 0, net work then positive. Heat absorbed or rejected. Heat will be absorbed. Q positive means heat will be absorbed by the gas. Similarly, counterclockwise or anti-clockwise. Counterclockwise cyclic process. So what is delta U? 0. Network done negative. It will be here. It is absorbed by the gas. Net heat absorbed by the gas here. So net heat rejected by the gas. The graph plays very important role here. Nobody will understand by looking at piston or something. The moment you show graph, everything will get, all the information is put in the form of graph. That's why I'm showing the graphical information. But practically this what goes on. Say piston moves and come back. You'll find very difficult to understand what's going on. If I just show in graph, no, okay, yeah, fine. So therefore, what all the thermodynamics concepts are there, no, I'm explaining through the graphs. So therefore, the understanding of graphs are very important. Okay, the gas will undergo process. This is 1, 2. This is a PV graph. Can you say about how the gas, it will start from here? Okay, or better we'll take this one. It will start from here. Fine. So afterwards, counterclockwise. First clockwise, then counterclockwise. So what about heat exchange in individual process? Then